All right, so we've just briefly talked about capital recovery and revisited that. Looking at the schedule, we've got the homework assignment due on Tuesday next week, so you've still got some time for that. And then a week from today, our first exam. And I previously mentioned to you that you should bring your laptop on the day of the exam because you're going to have an Excel question. And when you solve the Excel question, you're going to have to start with a blank workbook. So you can bring an equation sheet or a page of notes, whatever you like on that sheet. You can put anything you want. You won't have to copy any factor tables. I'll provide you those. I'm also going to give you the equation for any of the factors in case you get a question related to that. But what you may include putting on what you may consider putting on the formula sheet would be if you need a reminder of what should be the column headings. For example, if you're finding the future value of some cash flow. Because it's easy to forget in the heat of the moment if you don't have a lot of practice doing future values or internal rate of return, which we're doing today. Maybe just a reminder, an outline of what you need to do to get that started from the blank workbook. So we're going to do the exam a week from today, and then on Thursday the 23rd is when the project is due, the first project, because we have 2 projects in this course. All right. So any schedule questions before we talk about internal rate of return? All right. I got on the web today and I was looking at a couple of different bank websites. Actually, I only looked at 2. I should have looked at more because what I wanted to do, my objective in looking online, was finding 2 different banks that have different interest rates. Because I don't know why banks have such different interest rates when they're trying to originate loans. Sometimes it seems like they're trying to price themselves out of the market, like they actually don't want to be giving loans. For instance, Huntington charges 8.35% if you are taking out a loan on a 2023 model year vehicle. The interesting thing is that if you get an older car, the interest rate is higher. Do you notice how for a 2020 it's 8.46, 2019 8.71, 2018 8.75, and in fact it went even higher. I just truncated it, but if you get, I think, a 2015 vehicle, they'll give you a loan for it, but the interest rate is even higher. Why do you suppose they do that? Why do they care if you're driving a 2018 versus a 2023, and why would they charge a higher interest rate?
Would it be because by that time the car would have depreciated to more of its, less of its original value?
Okay, so Jake mentioned depreciation. I think that is part of it.
Is it not because people that usually buy older cars probably make less salary?
Okay, that could be part of it as well. Yeah. And so why are both of those things about someone having less of a salary, the car being more depreciated? I think that those are the underlying factors, but then from the perspective of the bank, why do they feel like they have to charge a higher interest rate?
Because they're loaning less money.
Okay, that might also be part of it. If they're loaning less money, then to make it worthwhile, they have to charge more. Okay. Yeah, I hadn't considered that, but I think you're probably right. Remember that interest rates, a lot of it reflects risk. And so what is like the risk of an old car versus a new car from the perspective of a bank? Why is an older car more risky for them? They're not the ones driving it. Why do they care?
Older cars, I guess, are more likely to break down.
Okay, but why is that a risk to the bank? Isn't that a risk to you, the car buyer? Because let's say, for instance, if your car breaks down and you have to pay a lot of money for it.
Is it because, like, say it breaks down, then the insurance would pay it right away instead of over time?
I don't think I don't know. Usually insurance would pay if there's an accident, but not necessarily, I mean, depending on what kind of a policy you have. You know, there are like extended warranty policies that maybe would pay out if they break down. But I think those are less common than just like collision type insurance policies. Well, let me pose you this scenario. Let's say that you've got a 2015 and it's more likely to break down than a 2023. And a 2015 is probably doesn't have any warranty anymore. So if it breaks down, you're going to be liable for the cost. And now it breaks down, you're financially stressed, and there's a risk that you may default. We talked about default as one of the main risks in lending. That is the risk that you're not going to pay back the loan, or if you're the bank, the risk that the person who borrowed the money isn't going to pay it back to you. So they view a 2015 vehicle as a more risky loan for them to make because, you know, it's more likely to break down, and then the person couldn't repay. But then I think a related part of it is, let's say that they want to repossess the vehicle. It hasn't broken down, but they want to repossess it. There's a possibility that once they repossess it, they couldn't sell it to somebody else for as much as still is owed on the vehicle. They sometimes call that being underwater on your loan. If you're underwater, that means that you owe more than it's worth. A lot of people, if they're in that situation, they'll just walk away. Like during the financial crisis of 2007, 2008, 2009, that financial crisis, a lot of people had homes that they purchased and financed when home prices were sky high. Then there was a crash in the market, and they walked away from their houses. They just mailed the keys to the bank and said, I owe you more than it's worth, so here's the underlying asset, the collateral. And so in the case of an auto loan, if the collateral is the vehicle, and the vehicle is already pretty close to the end of its useful life, then the bank sees that as risky. Because if they need to repossess the vehicle, it's likely to be worth less than the person still owes on it. So I think it's those combined elements of risk, the increased default risk, and maybe also the fact that, you know, the people who buy older cars are more likely to default. I can say that because I drive an old car. I drive a 2013, so I'm only denigrating myself. So it's more risky. So the interest rates are going up for the older the vehicle is, but this is Huntington Bank, 8.35%. Here is PenFed, a Pentagon Federal Credit Union. They will make the same loan on a 2013 new model vehicle, 72-month term, but they'll do it for 5.84%. That's a huge difference. And we're going to look at what a big difference that actually is, because you may think, that's not even 3% different. But over a long term, with compounding effects, that 3% can actually be pretty shocking how big the difference is. So let me just start up a spreadsheet here, and if you want to follow along, that's certainly great. And so let's put at the top of this the, oh, by the way, I didn't yet introduce what we're comparing these interest rates to. Let's say that you wanted to buy a new F-150. Boy, that's an expensive truck. It can be. I was looking, and the most expensive F-150 I could find was $105,000. There's one called a Snake, and there's another one called a Raptor. I don't know what the difference is. Which one's better, the Snake or the Raptor? The Snake's better? Well, if you've got $105,000, you can find out, because that's how much a new Snake cost, is $105,000. So I'm being really frugal here. I picked the less expensive option for this example. Let's say that you just go for the limited edition. It doesn't have the souped up engine, but it probably has leather seats at $86,000. Yeah, exactly. Nice wheels. $86,000 for this truck. So what we're going to look at is, do the interest rates matter? Looking at 8.35% at Huntington versus 5.84%. And let's just, for the hypothetical, say that you were going to buy this as a work truck. Now the reality is probably there's cheaper models for the work truck. You know, the stripped out one that has windows that aren't even electric.
My truck.
Your truck is like that? No electric locks,
No.
Okay.
No electric locks, no electric window.
less to break, right?
Yeah.
But it probably still goes from point A to point B, and you can put stuff in the back. So let's say in the case of this vehicle, what if you could use it and after the cost of fuel and insurance and all of the other operating expenses, let's say that it generates an additional $1,500 in net revenue each month. So what we're going to find out is whether that's justifiable. All right, no problem at all. Thank you. All right. All right, so should we do it? Should we buy this truck? Because is it going to pay for itself, depending on whether we get the loan from PenFed or if we get the loan from Huntington. So let me copy this so we can admire this beautiful vehicle that we're about to spend $86,000 for. And by the way, that's just the sticker price. You know that they're going to get you for extra for floor mats. Then they're going to want to give you the undercoat treatment. There's probably, definitely taxes, warranty, licensing. So it's going to be more than this. Okay, so the interest rate, what I mean per year, we're going to define here. These interest rates that are specified, that's the APR. And so that's the interest rate per year, annual percentage rate. Let's look first of all at the lower one from PenFed, which was 0.584, if I remember correctly. Let me just, 584, okay. The other one's going to be 8.35. So what if this is our interest rate per year, but the payments are per month? So the interest rate per month is that divided by 12. All right. And the initial purchase price, we're being optimistic here. We're not yet including the cost of license and tax and all that other stuff. $86,645. And so the monthly revenue that we think we're going to generate, the net revenue that's additional if we put this truck in service, is $1,500. Okay, so we're going to have month, amount, and PV of amount. And the whole reason we're doing this is just to compare the effect of these different interest rates. So I'm going to start at 0, 1, 2, and go all the way down through 72 months. Okay. Almost there. All right, 72 months. And then at month 0 is when we pay our $86,000, so minus of the initial purchase price. And then month 1 and all the others, I'm just going to refer to the revenue and anchor that reference. Drag it down. I can double click here and it will fill it for the rest of them all the way down through the 72 months. Okay. Now PV, the interest rate we're going to use is the interest rate per month. I'll anchor the reference there so it always look at that location. NPER is whichever period number we're in, so it'll be this particular month. And then each of these amounts is treated as an individual future value. So we got to skip over the payment field, and it's the minus of the amount that's there, and it's seeing that amount in the FV field. Okay, so it's not changing anything about the initial purchase price, but then all of the other revenues are being discounted to the present. So it's doing what we'd expect. For example, $1,500 1 month later is worth almost $1,500, but by the end of the 72 months, that $1,500 that we're making has less present value, and so we're taking into account the time value of money. Any questions so far? All right. So let's have here a total cell. So I'm going to have here the total of all the ones below it. So sum, and I want to have this sum. I usually sum it at the bottom, but because it's such a lengthy cash flow, okay, by the way, I want to show you a trick. If you do Shift, Control, and the arrow button, it goes to the bottom of the list. So you don't have to like drag all the way down. So here for the total, we're doing equals sum. You click on the first location, Shift, Control, and the down arrow, and it just takes you to the bottom of the list. Or we could do it the old-fashioned way, and equals sum, and just drag all the way down. Okay. So this is positive, which tells us this is a profitable venture, that the present value of the revenue is greater than the present value of the costs. So I'm going to just write a conclusion here. At 5.84% annual interest, the PV is positive. And that tells me that, you know, this is a potentially acceptable venture at that interest rate. Now, when I change to the other interest rate, when I change to 8.35, think about what is it doing to the revenue. If it's 8.35, those future revenues are being discounted more aggressively. So the cost is the same, but the revenue that you're making over time doesn't have as much present value to it. So it's going to make this total smaller because of the more amount of interest that we have to pay. So let's try that. 8.35% instead. Oh, by the way, I'm going to write the amount here is positive. 42.78. Just so I've got it documented here. Okay, so now at 0.0835, it's negative. So conclusion, at 8.35% annual interest, the PV is negative. Negative 1921. So if you can get this loan approved at PenFed, then maybe you should do it. If you have to go get the loan at Huntington Bank, where the interest rate is higher, then this is a losing proposition. The value of the revenue you're going to generate with the vehicle doesn't justify its purchase. So that means either you have to go get the model without leather seats, or take out the Bose stereo system, find a cheaper truck that makes it work, or maybe you have to get more hours so that you boost up your revenue, or just try and get the better loan. But this is illustrating an important point, and the point is that interest rates can make your project viable or unacceptable. So interest rates really do matter. Now, what does it mean it's negative versus positive? So the way I've been describing it so far, if you were going to take the loan to buy this truck, the revenue that you get each month, $1,500, some of that you get to keep and some of it you have to give to the bank, right? Because you're paying off that loan. So the portion that you get to keep is going to be positive if it's the lower interest rate, like over time, the value of the profits. But when it's negative, what that means is that you have to pay more to the bank on the loan than you're actually going to be getting back in the value of the revenue in the future.
So basically, the positive number, it's like the revenue you're gonna get at the end.
It's the present value of the revenue. So it's not just the total number of dollars, because you're going to earn more dollars than this, but if you took all of those dollars to times 0 and compared them to the dollars that you spent to get the truck, then there's more left over. There's more revenue dollars than cost dollars. Yeah. Okay. So should you do it? Yes at 5.84%, no at 8.35%. So rate of return, the internal rate of return, which we're talking about today, is assigned the variable I star. And you can think of it as it's the rate that you're going to earn on the unrecovered balance of an investment. And this phrase unrecovered balance will make more sense on Tuesday next week, because we're going to talk about it more. But when you invest in something and you haven't got all of the revenue out of it yet, that unrecovered balance is how much did you invest versus how much you haven't got back yet. So when you buy the truck, let's say, what if you bought the truck with your own cash instead of taking money from the bank? If you bought it with your own cash, then that revenue that's coming in every month is going into your pocket and is justifying how much you spent up front to acquire the vehicle. So unrecovered balance is just the idea that you have to be using the equipment for a certain amount of time before that initial purchase was justified. So that's one way to think about internal rate of return. The other way is if you've borrowed money, then it's the rate that you pay on the yet unpaid balance. The reason why it's called internal is if you have purchased some sort of an investment that's paying you money, internal rate of return assumes that all of the money you get, you're reinvesting into the same thing. So like a savings account, for example. If you put money into a savings account, the bank usually won't mail you a check with the interest every month. They'll just put it into the account. They'll keep that earning internal. So internal rate of return is different. We will talk about in a couple of lectures something slightly different called external rate of return. It's more complicated, but in the case of internal rate of return, it's assuming that the money is being reinvested into the same account. We've talked about balance. Remember the slide that showed the rocks that were balancing on themselves, or the elephant on the ball? The idea of balance between inflow and outflow. That is internal rate of return. When we calculate some unknown interest rate that brings equilibrium between inflows and outflows, that is internal rate of return. So the procedure, and we're going to apply this procedure in the in-class example today, is all of the amounts have to come to the present. So you're going to discount anything in the future, and then you're going to be looking for an interest rate that makes the sum of all of those inflows and outflows equal to 0. So we'll use goal seek, and our goal is that the sum of the present worths should be 0. So this scale is depicting the fact that internal rate of return is balance between inflow and outflow when all of the amounts have been discounted to the present. You can only calculate internal rate of return if there are revenues and if they exceed the cost. There's no such thing as a negative internal rate of return. If you try to calculate internal rate of return and there's more outflow than inflow, you'll just get a formula error. And we can solve it either using an Excel function, or we can solve for it graphically. And I think I've shown the next slide earlier in response to one of Jace's questions. We'll talk about that in a minute. But when you're making decisions and trying to decide whether a project is acceptable, the way we know whether a project is acceptable is if the internal rate of return is greater or equal to the MAR, then you could accept the project. but if the interest rate that the project is going to make is less than the minimum, then it should be rejected. That's pretty straightforward criteria, but there's a warning that comes with it. We can use this internal rate of return to give a thumbs up or a thumbs down for a project, but we can't rank projects by their internal rates of return. I'll show you a proof of that in a later class, but you don't know which project is best by internal rate of return analysis. You only know if it's acceptable. So just to summarize, we're taking all the amounts, both revenues and expenses, to the present. And the interest rate that makes them equal is the internal rate of return. So here's a formula that summarizes that. It's saying the present worth should be equal to 0 at some unknown interest rate. And the interest rate that makes the revenue and the expenses equal to 0 is the internal rate of return. So you'll notice that all of the revenue amounts, years 0 through year n, you're finding the present value of each of these individual future amounts. And we're doing the same thing with the expenses. And so balance between inflow and outflow is the internal rate of return. So this is the slide that I showed to Jace and all of you a couple of lectures ago, where we looked at if the present worth is positive versus if the present worth is negative, and that crossover point between positive cash flow and negative cash flow is the internal rate of return. So we'll be solving this today in the in-class exercise. We'll try one interest rate that gives us a positive present worth, another interest rate that gives us a negative one, and then we'll use goal-seek to try and solve where is the crossover point, what interest rate, the x-axis here is interest rate, what interest rate gives us 0 present worth, because that is the internal rate of return that we're trying to solve for. So here's just a reinforcement of that warning that I told you a moment ago, that you can use this IRR to decide whether a project is acceptable, but you can't use the IRR to compare one project to another. And let me just very briefly give you a hypothetical. What would you rather have? An account that pays 10%, but you can only invest $100 in it, or an account that pays 8% and you can invest $10,000 in it? Well, you're going to make more interest on the lower rate opportunity because you can put more into it. And so that's why you can't just go by the interest rate to know which opportunity is best. But if you know that for you, your personal minimum attractive rate of return is 5%, either of those options I mentioned to you is potentially acceptable. You would take an 8% opportunity, you would take a 10% opportunity. Both of those are okay if for you 5% is acceptable. But we can't just look only at the interest rate. There's other things that determine which is the best option besides just the interest rate. So that's the warning. And then the other thing to keep in mind is that there's an assumption that the cash flow which is generated is reinvested in the project or at the internal rate of return, the same interest rate. So a bank account is valid. You know, you will have the opportunity to reinvest your earnings in a bank account. But what if you started like an ice cream store and it was $10,000 to buy the equipment and refurbish the space? So that original $10,000 was your investment, and then you're getting some revenues over time. Maybe you can't reinvest those revenues into the ice cream store because you've already bought everything you need. So IRR assumes that all of the cash flow you're generating is being reinvested into the project or into something else that yields the same rate of return. But if you're taking money from your ice cream store and putting it into just a savings account, then those would be two different rates. The rate that the money is being generated by the business and then the rate of return you're getting from the bank account. And it's that situation where there's two different rates where we have to use external rate of return. Internal rate of return assumes that there's only one interest rate and that your reinvestment and that your compounding occurs at just that single interest rate. So we'll come back to that. That's a complicated idea. You may not be able to wrap your mind around it all the way tonight, and that's okay. But what we should do is take a look at this example. I've given you a cash flow diagram that you need to translate into a cash flow table, and we're finding the present worth. So, in advance of our exam, let me just give you an illustration of like how you could give yourself hints on that formula sheet. So, you know, to find PV, you'd maybe say, okay, I'm going to have an interest rate cell, and then year, amount, PV of amount, and then there's data, and then sum. So that's just kind of like a reminder of the structure of the spreadsheet. It's okay for you to have notes like that on the little paper that you bring for the exam. So on this, you've got a cash flow diagram. So start up Excel and find out if you have 7% interest, what is the sum of the present worths? And then what about at 8%? And I think what you'll find is that at 7%, one of them is negative. Positive. At 8%, it'll be negative. And so the crossover point, the internal rate of return, is where it goes. We could do linear interpolation, but this is going to be 7%. This is going to be 8%. We want to find out what percent is it where it goes from positive to negative. All right, so I'll pause for a moment and let you get started on Excel. Catch up to you. I think everybody's kind of ahead of me at this point. So at 7%, it's 26,905. If I do it at 8%, 0.08, then it's negative 15,074. Now let me write this on the board because these are the amounts. So 26,000. Here is 26,096 at 7%. At 8%, it's minus 15,074. Okay. So we could do like linear interpolation, but the problem with linear interpolation is that it's actually not a line, that it's actually a curve. You know, that interest rate, well, it's a curve. So if you linear interpolate, you're going to be slightly off. So we'll just do it the way that's described in the in-class exercise here. It says that use goal seek to find the internal rate of return that takes it to 0. So we want this to be 0 by changing the interest rate. So now I'm going to say I star is, okay, so I'm going to use goal seek here. Data, what if analysis, goal seek, and our goal is for the sum to be 0 by changing the interest rate. Okay. There it goes. 7.63%. So 7.63%. So that's the internal rate of return. So that means, like, if you could take all of this revenue and reinvest it into this same business, then the rate of the overall net rate of return, including compounding, is 7.63%. Now the handout has, it says here, use the IRR function to find I star. Okay, so there's a function called IRR. Anytime there's a new function, even if you've never used it before, Excel will give you little hints. So let's just here try, okay, using IRR function. Okay, so equals IRR and parentheses. So now it's just asking for all of the values. And so select the amounts, not the PV of amounts, just the amounts. And it's going to automatically return, if we increase the accuracy here to show more digits on the percentage, it's that same 7.632507, same that we calculated the other way.
It gives me 8%.
Yeah, you just need to show more digits.
Yeah.
Okay, so that's internal rate of return. Any questions about the first problem? Okay, the backside has a question related to capital recovery and internal rate of return. So let me pull up that problem and get it on screen. So this is similar to that illustration I had on the whiteboard earlier, where we are paying a certain amount up front. So if we were going to think about a cash flow diagram here, we pay $35,000 today at the present, and then it's going to generate a certain amount of revenue each year, and then is sold for $1,200. So capital recovery doesn't know how much revenue is generated. We're going to use this revenue generated statement when we calculate the internal rate of return, but how much revenue is generated does not influence the capital recovery calculation, because the capital recovery calculation only depends on the present value taken to an annual series and the future value taken to an annual series. So remember, there's a function in Excel. Have we talked about the payment function yet? PMT? No? Okay, well good. I'm glad that we're going to cover something new with this example. Let me just do a screenshot so I can paste it into another workbook. All right. So let's start with the capital recovery. there's a function in Excel that will save us the trouble of having to do find a given P at some interest rate for some N. You know, find a given P, like this is what we would use if we were calculating our own factor or looking up the factors from the tables, but we've never done like this in Excel. So if we want to find a given P, there's a function that will allow us to do that. So let me say here is the PV that we already know about is negative 35,000. That's how much we had to spend to buy it. Okay, and here is FV. It is $1,200. And then there's some interest rate that applies here, 5%. Okay, so now we're going to find how much is the FB worth as a annual series. It's going to be arrows that are up. So we want to find what's the annual equivalent of the future value. So annual equivalent of the FV. Okay, so I'm going to do, I'll give you a minute to type that in, and then I'll show you the function. I guess I could turn that into currency just to be consistent here. Okay, so here's the payment function, equals PMT, parentheses. Okay, it's asking for the rate, okay, 5%. I'm just clicking on that cell location. I don't need to drag it down because I'm just typing this in this one time. So I'm not going to bother anchoring the reference. So 5% NPER. 7 years, okay, so I'll just type in the number 7 for 7 years. Okay, next. Okay, it's asking me what is the present value. Well, that's not what we're talking about right now. We're talking about a future value. So I'm going to skip over that. And then the minus of the future value, because I want to know what is the annual equivalent of the future value. Okay, so what it tells me is you can either have a lump sum payment of $1,200 in year 7, or you can have 7 payments of $147.38. Those are economically equivalent. We can do the same thing about the present value. So annual equivalent of the PV, and now we're annualizing the purchase price. Using the PMT function here. All right, so equals PMT. Again, we'll refer to the 5% interest rate. NPER is 7 years. Now, it's asking, what is the PV? So I'm going to say it's minus of the amount that we know. I always have to put the minus sign in because otherwise Excel is going to flip it.
What if you already had the minus sign?
Well, there's a minus sign here that I know means an outflow.
Oh, okay.
So if I don't have this, it's going to change an outflow to an inflow. Okay. So what it's saying is a lump sum of $35,000 at time 0 is the same economically as 7 annual payments of, what is it, $6,048? Okay, so then the capital recovery is the difference between the two. Okay, so capital recovery, it is, add them together. So the other way to think about this is how much revenue would you need to earn each year to justify the equipment? $5,901.31. Luckily for us, it's generating $8,400. So it seems like this is headed in the right direction. If you generate more revenue than your capital recovery, that's great. If you don't, you can't even pay off the equipment, much less the people, the operating expenses, and so on. Jace, do you have a question?
Can you explain what the 147 is again?
Yeah, that is the annual value of the salvage. So either $1,200 at year 7 or 7 equal payments of 147.
Okay.
So either way, you have to annualize the future value and the present value when doing capital recovery.
Yep. The PMT function is find A.
Gotcha.
Interesting thing about it is we could put both the future and the present value into the PMT function at the same time. I didn't initially, but let's try it again. Add both PV and FV into PMT function. Just to show you that that's possible, equals PV. Okay, our rate is 5%. Rn is 7. Oh, sorry, I typed in PV. I need PMT. Okay, sorry. PMT. All right, rate 5%. NPER 7. Okay, now it's asking me for the PV. So I'm going to have, in this case, it's 35,000, yep. So minus of this amount, and for the FB, minus of that amount. And it gives me this $5,901. So you can put both the present and the future, and then it finds the net annual difference for both of them. So that's the PMT function. Pretty useful. So that's the capital recovery amount if it's 5%. Now let me pause for a minute and then allow you to calculate the internal rate of return. So internal rate of return, remember, is we set up this spreadsheet. We play around with the interest rate until the present value is equal to 0. What Victor remembered was you don't even have to do this column to calculate the internal rate of return. Victor remembered there's this function, the IRR function equals IRR, and you just put in the amounts and it will calculate. It looks like 15.37%. My idea was that you'd do it this way and play around with the interest rate just for the practice. So let's see if it gets the same value. I put in a guess interest rate to begin, and then I'm going to have to change it until I get the sum that I'm looking for. I clicked in the wrong place. I think we got it, 15.37%. Whether we do it the manual way or whether we do just the IRR function, we get 15.37% for this.
Oh, good. I like it.
Well, let's take a look. Internal rate of return, does anybody remember what's the warning about applying the IRR for decision making?
You don't want to compare it to.
Don't compare rates of return, but you can use it for initial screening.
It should be.
The proper application is a thumbs up or thumbs down, acceptable or unacceptable, initial screening. But for choosing which option is best, we have to do something different. So that's the warning. And then what's the assumption with internal rate of return? Well, it assumes internal reinvestment. So all the money that's being generated goes back into the same project or some account that gives you the same rate of return. So sometimes that's true, other times it's not. That's all for today. Remember our schedule here. Homework next Tuesday, exam next Thursday, and then Thursday after that's the project. All right. I'll see you next week.